Welcome everyone. Today I will discuss how to find area bounded by plane curve. So to solve problem of this chapter, we need how to integrate, that is how to find value of indefinite integral. So we need idea of integration. And number two, we need idea of graph of function. Only the basic functions, straight line, circle, parabola, hyperbola, ellipse, sine curve, cos curve, tan, cot, mod x, mod curve, and some exponential logarithm. These ideas are necessary. So we have already taken 4 classes for sketching of graph. So we need idea of graph also. Today I will discuss only the basic concept of area, how to find area bounded by plane curve. So for board problems only. Now what is geometrical significance of integration a to b fx dx? So y equals to fx is curve. We do not know the form of fx. It may be straight line, parabola, any curve, and it is bounded by x equals to a, x equals to b, and x-axis. So what is geometrical significance of a to b fx dx? So a to b fx dx. Look, from this figure, the curve x1a, x1b, and x-axis also represents area bounded by y equals to fx, x equals to a, x equals to b, and x-axis. So area equals to integration a to b fx dx. That is a to b fx is y. So this is formula of finding area bounded by curve, 2 ordinates, and x-axis. So this is geometrical significance. Now application. Geometrical significance, that is area. Now application. Find area bounded by y square equals to 4x and its lattice vector. Find area bounded by this parabola and x-axis. So problem number 1. So look, we need idea of graph. So area bounded by y square equals to 4x. This is a rough sketch. Y square equals to 4x, parabola, y-axis, x-axis. Now lattice rectangle passing through focus and perpendicular to the axis L1, L2. So this is A0. So area bounded by parabola and lattice rectangle is this portion. But we know area bounded by 2 ordinates and x-axis. So look, the portion above x-axis, this one, it is bounded by x equals to 0, x equals to a, and the parabola. Therefore, we can find the area of the portion above x-axis. Now, due to symmetricity, area below x-axis also same. So, we have to multiply to find total area, multiply with 2 of area above x-axis. So, what is area of the shaded portion? Area of the shaded portion equals to 2 into 0 to a y dx. So 2 into 0 to a root over 4a x dx. So this is, now we need idea of integration. 2 outside, root a outside, x to the power half. So x to the power 3 by 2 by 3 by 2, 0 to a. Now if we simplify, this is 2 by 3. So 8 by 3 root a into a to the power 3 by 2. So 8 by 3 is square. So this is area of the total part. If it is stated that area above x-axis, then only y dx, that is 4 by 3 is square. So area is this square unit. So 0 to a bounded by curve and x-axis. Now problem number 2. So area bounded by y square equals to 2x and y square equals to x square minus 2x and x-axis. So this is parabola. Y equals to x square minus 2x. This is 1. So x-axis is y equals to 0. So two ordinates are not given directly. So we find by solving 1 and 2. So 1 and 2 implies x square minus 2x equals to 0. So x into x minus 2, 0. So point of intersection 0, 0. X equals to 0, y equals to 0 and 2, 0. This is point of intersection. Now we have to draw graph of y square equals to 2x. Now y square, this is axis is parallel to, this is of this form, y minus beta whole square 4a into x minus alpha. Alpha beta is vertex. Now y square minus 4x, and this is general one. So it cuts x-axis at 0, 0 and 2, 0. This is 2, 0. So how we draw the curve? So y square equals to x square minus 2x plus 1 minus 1. This is not y square, so this is y. Y equals to, so y plus 1 equals to x minus 1 whole square. Look, to draw graph, we need vertex and axis. So what is vertex? Vertex is 1 comma minus 1 and axis is obtained by considering square term at 0. So x minus 1 equals to 0, x equals to 1. So to draw graph of parabola, we need vertex. Vertex is 1 comma minus 1. This is 1, 1 comma minus 1. And axis is x equals to 1. This is x equals to 1. This is vertex. Now coefficient of x square is positive, so it is open vertically upward. So figure will be like this. So this is the parabola. This one. This is parabola. You can also draw by shortcut method. Look, 0, 0 and 2, 0. This is point of intersection. Take midpoint and this will be axis. So it passes through 0, 0 and 2, 0. And since it is, look, open upward, so vertex will be here, because to pass through these 2 points, vertex will be to 4th quadrant. Otherwise, you get figure like this. So, and this one is general method. So this is the shaded portion. Now you know x equals to 0 to x equals to 2 and the curve. So you can find the area. So what is area? Area equals to 0 to 2 y dx. Now since it is below x axis, we can take minus y. If it is below x axis, we take minus y dx. Or we integrate, then take modulus. Or you can write 0 to 2 y dx modulus of this, as you please. So it is real picture, so you are sure that it is below x axis. So minus y dx we get. So 0 to 2, what is y? X square minus 2x dx will be negative sign. Now integration 2. So x square minus x cube by 3, 0 to 1. So 1 minus 1 by 3, so 2 by 3 square unit. Now problem number 3 and 4, they are of same type. Area of circle, area of ellipse and also height. They are of same type. So write problem number 4. Area of ellipse. So draw the ellipse. X square by a square, y square by b square equals to 1. So what will be figure? Look, x axis. This is y axis. This is x dashed. This is y dashed. Now, area of ellipse, x square by a square, y square by b square equals to 1. So A dash is major axis. This is A0. B dash is minor axis. So this is our figure. You have to find area of the shaded portion. So to find area, we need 2 ordinates. Look, this is x equals to 0, this is x equals to a, the curve and x axis. So we can find area of the first quadrant. And due to symmetricity, area of the ellipse will be 4 into area in first quadrant. So area in first quadrant equals to 0 to a, we know formula y dx. Now this curve is x square by a square, y square by b square equals to 1. So what is value of y? Look, y square by b square equals to 1 minus x square by a square. So y equals to b by a root over a square minus x square. So we need value of y. So this is b by a root over a square minus x square dx. Now it is problem of integration. So b by a outside. Now formula of root over a square minus x square. a square minus x into this plus a square by 2 sine inverse x by a. This is most important formula to find area. Very simple, you have to recall it. A square minus x square. You know, this is problem of integration by parts. So formula is a square by 2 sine inverse x by a plus c also. Now it is definite integral 0 to a. So b by a outside. If you put a, so this one is 0. So a square by 2 sine inverse 1. And if you put 0, this is 0, a square by 2 sine inverse 0. So we get b by a into a square by 2 into pi by 2. So ab, pi ab by 4. Pi ab by 4. So it is area in first quadrant. Now area of ellipse due to symmetricity. What is area of ellipse? So area of ellipse equals to 4 into area in first quadrant. Area in first quadrant. So 4 into pi ab by 4. So you recall it. This is pi ab square unit. Now circle b equals to a. So pi a square. It is verified. It is verified. Now problem number 5. So find the area of the smaller portion of the circle x square plus y square equals to a square curved by x equals to a by root 2. So circle center 0 0 radius a. Center 0 0 radius a. This is a 0. And it is curved by a by root 2. A by root 2. So look, circle is divided into two parts by this line. So we need area of the smaller portion. So this is a by root 2 and this is x equals to a. And this is curved. So you can area in first quadrant. So required area equals to twice into area in first quadrant. So it is, so area equals to 2 into, this is x equals to a by root 2. A by root 2 to a, y dx. So 2 is coming for symmetric part below x-axis. So 2 into a by root 2 to a, what is y? Y is a square minus x square dx. Now you find value of integration. 2 unchanged. X into a square minus x square by 2, a square by 2 sine inverse x by a, and this is a by. You simplify and find the area. Now formula number 2. Significance of c to d phi y dy. So suppose this AB is curve represented by x equals to phi y. And this is y equals to c and y equals to d, abscissa and the curve and y axis. You are getting this shaded portion. So c to d phi y dy, what is significance? Represents area bounded by x equals to phi y, the curve, y equals to c, y equals to d, and y-axis. So what is area? C to d, phi y dy. So what is phi y? X dy. So this is formula if area bounded by y-axis. So C to D x dy. Now application. So right, find the area bounded by x equals to y square minus y and y-axis. Area bounded by x equals to x equals to y square minus y and y-axis. So curve is y square minus y and y-axis x equals to 0. So solving, we get point of intersection as y square minus y equals to 0. So y 0, y 1 and x is fixed. So point of intersection 0, 0 and 0, 1. So this is parabola y square minus y. It cuts y-axis at 0, 0 and 0, 1. 0, 1. So this is, so what is midpoint? Midpoint is this. So this is axis. We have already stated shortcut rule, axis. Now coefficient of y square is positive. So if it is y minus beta whole square, 4a into x minus alpha. So figure is this type. If a is positive. So it passes through 0, 0 and 0, 1. So in second quadrant, vertex will be in second quadrant. So this will be the figure. Y square minus y equals to x. Or you can express it in this form as you please. So this is our area. So it is bounded by y-axis. Y equals to 0 and this is y equals to 1. So area equals to 0 থেকে 1 x dy. Now look it again. It is left of y-axis. So we have to take minus. Otherwise mod symbol. So we are drawing a real figure. So you take minus x. So 0 to 1 minus y square minus y dy. So y. So y square by 2 minus y cube by 3. 0 to 1. So half minus 1 by 3. This is 1 by 6. So this is one application. How to find area if it is bounded by y-axis. Now we find area bounded by two curves. So y equals to fx and y equals to gx are two curves. And two ordinates x equals to a, x equals to b. Within a and b, two curves do not intersect. So we are getting x equals to a, this is x equals to b, so this figure. Now what is area of the shaded portion? Area equals to, look, if we take the curve y equals to fx, x equals to a, x equals to b, and x axis. We are getting the whole figure. And if we subtract the lower part, we get required area. What is lower part? A to b gx dx. So area equals to integration a to b fx dx minus integration a to b dx dx. So same limit of integration fx minus dx. So here it is obvious that fx is above gx. Otherwise, we have to take modulus of fx minus gx, then total modulus. So this is area bounded by rule of finding area bounded by two curves and two ordinates. Now, application. So, if the area bounded by y equals to fx, y equals to x square by 2, between abscissa x equals to 2 and x equals to alpha, alpha greater than 2 is this, then find fx. It is also given fx lies below the parabola. So, y equals to x square by 2. So, x square equals to y minus 2. So, y minus 2, 0 2 is 0, 2 is vertex and axis is x equals to 0, that is y axis. So, parabola is, if it is 0 2, so this is parabola. Suppose this is 0 2. So, and one curve is given. We do not know the form of fx. Suppose this is y equals to fx. It is given that y equals to fx is below the parabola. So, this is not known curve. So, area bounded by x equals to 2 and suppose this is x equals to alpha is given by this portion. So here no need of figure also, because problem is given in direct form that this is above. So what is area? Area equals to 2 to alpha. The curve, this one, so f1x, that is x square plus 2 dx minus 0 to alpha fx dx. 2 to alpha fx dx. So no need of figure, because it is given that fx is below this. So we can write also what is area? Alpha cube minus 4 alpha square plus 8, 2 to alpha x square plus 2 minus fx total dx. Now we integrate it to find fx. So fx, form of fx is not known, so you cannot find it by integration. So we use Leibniz rule. So differentiating both sides with respect to alpha. So 3 alpha square minus 8 alpha equals to. So integration is omitted and x is replaced by alpha. So alpha square plus 2 minus fx. Then derivative of the upper limit. Derivative of the upper limit, alpha with respect to alpha is 1. So this one is f alpha. Since lower limit is constant, derivative of lower limit is 0. So no need of second part. So what is fx? Fx equals to We are transferring fx to left hand side. So minus 3 alpha square plus 8 alpha plus 2. F not fx, this is f alpha. So alpha cube, 3 alpha square. So alpha square, this is minus 2 alpha square plus 8 alpha plus 2. So if you get f alpha, then you can find fx. So look, 2 curve bounded by 2 elements. So formula is this, use Leibniz rule. This is most important, Leibniz rule. So find fx. Fx is given by minus 2x square plus 8x plus 2. Now we find area bounded by two curves, y equals to fx and y equals to gx. Here two curves intersect. What is the difference? For the previous one, fx and gx are not intersecting. That is why we are finding area between x equals to a, x equals to b and two curves. Here two curves are intersecting. So a to b fx dx. So what is a and b? A and b are x coordinate of point of intersection of two curves, and it is also given fx is greater than equals to gx. So fx and gx are two curves. This is fx and this one is gx. So they intersect at a. This is a and this one is b. X equals to b. So this part. Here curves are intersecting. So no need of giving x equals to a, x equals to b. So a to b, upper curve fx minus lower curve. So you get area of the shaded portion. Now if it is not known which one is above, here fx greater than equals to gx is given. So if this condition is not given, so we take this one as total mode. So rule is difference of two curves and intersection. One intersection, this is second intersection. So when two curves intersect, we use this formula. So application. Now application. Area bounded by two intersecting curves. If two curves intersect. So problem number 1. Find area bounded by y square equals to 4ax and y equals to mx. So we first find point of intersection of two curves. So look, m square x square equals to 4ax. So x common, m square x minus 4a equals to 0. So x equals to 0, x equals to 4a by m square. So point of intersection. So for both problem, if you find up to this point of intersection, you get 1. So 4a by m. mx, 1m is cancelled. So we need only the x coordinate. So draw the figure. So y square equals to 4ax. And this is y equals to mx. and this is y square equals to 4x. Y square 4x. So area bounded by is given by this part. So this is O and this is P, point of intersection. So draw P and perpendicular. So this is the second point. So figure will. So if you draw rough sketch, you get 1 marks for both problem. So what is x coordinate? 4a by m square. This is 4a by m square, comma 4a by m. So we need x coordinate only. This is 0, 0. So what is area? Area equals to area 0 to 4a by m square. So y of parabola dx minus y of straight line dx. Y of parabola, y of straight line. So parabola lies, look, fx, y square. This is y greater than, for y1, this is y1. This part is above than this, within the point of intersection. So 0 to 4a by m square. So what is y? Root over 4ax dx minus mx. So 2 into root a outside. This is 2 by 3 x to the power 3 by 2. Suppose 0 to 4a by m square. And this is m outside, x square by 2, 0 to 4a by m square. So we need calculation only. So 4 by 3 root a. So x to the power 4a by m square whole to the power 3 by 2 minus m by 2 16a square by m to the power 4. So 4 to the power 3 by 2 is 8. So 32 by 3 a square by m cube minus 8a square by m cube. So if we simplify 8, 32, so 24 minus 32, so 8a square by e m cube square root. So y square equals to 4x and y equals to mx. You have to recall this result if possible, because for competitive exam, West Bengal JEE, this is problem of 1 marks. So if you remember the result, so put the value and you can solve it within second. So for the second one, same result, symmetric parabola, so 8 square by 3m cube. For the third one, so look, a equals to 1 and m equals to 1, so 8 square by 3. For the fourth one also same. So how to find area bounded by two intersecting curves? Now we find area bounded by y equals to sin x and y equals to cos x between two consecutive points of intersection. So same procedure, if they are intersecting, y equals to sin x, y equals to cos x. So tan x equals to 1, tan pi by 4. So x equals to n pi plus pi by 4. So point of intersection, x coordinate of points of intersection. For 0, this is x equals to pi by 4 and x equals to pi by 4. This is our first phase. To find point of intersection. Now, x coordinate of point of intersection x1 pi by 4 and 5 pi by 4. Now, draw the graph. Suppose intersection is pi by 4 to 5 pi by 4. So, we draw the graph within 0 to 2 pi. So, this is pi, this is pi by 2, this is 3 pi by 2. So, this is 1 and this is minus 1. We know maximum value of sine is 1, minimum value. So, sine curve at pi by 2, this is 1. So, pi to 3 pi by 2. So, 3 pi by 2, this is minus 1. This is y equals to sine x. 3 pi by 2, this is minus 1. And for cos curve, cos pi by 2 is 0, cos 3 pi by 2 is 0, cos pi is minus 1. So, this is cos curve, and at pi by 2, 0 it is 1. It is 1. At 2 pi it is also 1. So, this is y equals to cos x. So, look, we are getting 2 points of intersection P. This is pi by 4 and this is Q. This is 5 pi by 4. So, it is a point, this one, this is curve and this is another curve. This is point of intersection, this and this. So, this will be our required area. So, from symmetry, this and this are same. So, suppose this is A, above x-axis is A. We have to find twice of A. So, if we take above x-axis, then integration have to perform pi by 4. Now, we are interested to find area above x-axis. So, above x-axis is pi by 4 to pi. Then we are getting this whole part. You have to subtract this portion only. Pi by 4 to pi by 2. So, area above x-axis. Area above x-axis equals to pi by 4 to pi. This curve, this is sine curve, sine x dx, minus pi by 4 to pi by 2 cos x dx. This one is cos curve. So, this is minus cos x pi by 4 and this is minus sine x pi by 4 to pi by 2. So, minus cos pi minus cos pi by 4 minus sin pi by 2 minus sin pi by 4. So, cos pi is minus 1 and minus 1. This is also plus 1 by root 2. This is minus 1. This is plus 1 by root 2. So, root 2 unit. 1 cancel. So, root 2. So, required area. So, required area equals to twice into root 2 square unit. So, this is a rule for finding area bounded by two intersecting curves. And finally, there is one more. Now we find area bounded by y equals to fx and gx in a less than x less than equals to b when they intersect at single point within the said interval. So, y equals to fx, this is curve 1. and this is y equals to curve 2. So this is x equals to a. We are getting this part and we are getting second part. So what is area of the part? This part. This is a1. So integration a to c. This curve is above. So fx minus gx plus this curve gx is above. So c to b. Within c to b, gx is above. Gx minus fx. So a to b mod fx minus gx. You can write it in this form. So it is property of definite integral. So you know a to b fx dx, c is a point, a to c, c to b. So if two curves intersect at one point within its domain, then this is our formula. Now application. Area bounded by y equals to sin inverse x, y equals to cos inverse x, and x axis and x axis. So area bounded by y equals to sin inverse x and cos inverse x. So sin inverse x equals to cos inverse x. So they intersect at x equals to 1 by root 2. X equals to 1 by root 2. Sin inverse 1 by root 2. So sin inverse, so this is pi by 4, this is pi by 4. So point of intersection. So sine curve at 0, this is pi by 2. Suppose this one is pi by 2. Sine 0 is 0. Sine pi by 2 is 1. So pi by 2 is 1. Sine pi by 2 is 1. Sine 0 is 0. So the curve is so if we draw this curve, sine curve, y equals to sin x, its mirror image about y equals to x. So this is y equals to sin x, sin inverse x, and y equals to cos inverse x. At x equals to 0, it is 1. At x equals to pi by 2, it is 0. So this is y equals to cos inverse x, y equals to sin inverse x, and they intersect at P. So P is 1 by root 2, x equals to 1 by root 2. So find the area bounded by these two curves, this curve and x-axis, mind it. So this is area. This is our area. So what is area? Area equals to, look, 0 to 1 by root 2, sin inverse. 0 to 1 by root 2, y dx. So sin inverse x dx. Now it is not minus 1 by root 2 to 1. 1 by root 2 to 1. Cos inverse x. Yes. Cos inverse x to dx. This is, so you can integrate by parts, then find area. So you complete it. Sin inverse x, you know you have to integrate by parts. So sin inverse x into x minus. So this is 0 to 1 by root 2 minus. This is integration 1 by root under 1 minus x square into x dx. So 0 to 1 by 2. So similarly for second one, x into cos inverse x. This one is 1, this is 1 by root 2. Plus, it will be plus x into root under 1 minus x square dx. So integrate and you get area. So we have discussed today how to find area of plane curve. So we have considered 5 possible cases. Area bounded by single curve, 2 ordinates and x-axis. Number 2, area bounded by y-axis, y equals to c, y equals to d and x equals to phi y. That is area bounded by y-axis. Number 3, area bounded by 2 curves and x equals to a to x equals to b. So we have solved application and we have done application for each formula, 2 or 3 problems. Number 4, area bounded by 2 intersecting curves. And number 5, area bounded by 2 curves in A to B if we get only one point of intersection. So these are the rules. From the next class, so I have taken 6 classes to find area. Next class we solve problems of these chapters. So thank you.